Hello, Calc class. I hope you did well with your last assignment. All right, this one here is 3.3. It's slope, and we've been doing slope since you were little, right? Except now we're going to do it with limit, and we're going to do average slopes and velocities and all kinds of fun things. And let's get moving. So make sure you got your 3.3 notes out. Let's see what we got. All right, we're going to calculate the average rate of change. We're going to calculate the instantaneous rate of change. So that's at a very specific point, and then we're going to do some story problems with it. Okay, you remember rate of change means slope, which is change in y over change in x. The other formula you kind of got to remember is distance equals rate times time. That's just a reminder. All right, we know the distance from San Francisco at time t. So how far away are we? So this is our hour. So we're 0 hours where distance is 0 miles. We haven't gone anywhere. In a half hour, we moved 30 minutes. In 1 hour, we've gone 55. So we're kind of speeding up a little bit here, right? Or slowing down, actually. And we just keep going. Now, I want to know my average speed from 0 to 3 hours. What I'm going to do is take the speed of where I ended and where I am and find that average. That's all I'm doing here. Nothing too exciting. So to do that, we take, the speed at s of 3, or that distance, which is 138 minus the distance at 0, which is 0, over the 3 minus the 0. So you just take 138 divided by 3, and it's 46 miles per hour. Going kind of slow. Actually, kind of depends on where you are. I'm sure you got some in-traffic time there. All right, so the slope is always the y value, which is f of b, minus the f of a. Remember, these mean y, minus y over x minus x. Nothing is different, just the notation. We are using function notation. So find the average rate of change from 2009 to 2013. Pause and do this. So you said in 2013, you should have had 65.7 minus 2009, which is 63.52, all over, 2013 minus 2009, and your answer should have been 0.54. And what is this? Millions of dollars per year from your size. Okay, all you're basically doing is you're making this year into a straight line. You do that a lot in chemistry. Physics, I think, is what it is. Okay, instantaneous rate of change. So this is the rate of change at a very specific point. All right, so this is generally a line. We're going to make a tangent when we get there. Now, so suppose a car is stopped at a stoplight. Okay, let st equals 3t squared. Now, it represents the distance the car travels t seconds after the light turns green. So how far have I gone? Find the distance 10 seconds after the light turns green. So now I want t to be 10. All right, so now if we do intervals, we go 10.1 minus 10 is, you plug it into our formula above there, you get 306.03 minus 300 over 0.1, right? And I could do 10 to 10.01 and then 10 to 10.001. Remember our limit where we just kept getting closer and closer to 10? That's what this is doing. So if you look, it's getting closer and closer and closer to 60. Now, we don't want to do all that work. So first, let's look for a pattern. And if you look, what we're doing is we're taking 10 plus x, right? Minus your original all the way through, all over the 10 plus x, all over the x. So this is 10 minus this, so your x was 0.01, right? That's all we're doing. This is our pattern. Okay, this is called instantaneous rate of change. I think it should look, why does this keep jumping? Very familiar to you. All right, so we got h, the limit as h approaches 0 is all we're adding. So we got f of a plus h minus f of a divided by h. Look familiar? Hoping you're saying yes. Okay, when we go through, now let's do this. So the limit of 10 plus x minus s of 10 over x is what we're doing. So we're going to plug this into our formula. So this is 3 10 plus x squared minus 3 times 10 squared all over x. Square this out, combine our like terms, divide by x, and we get this. But now as x approaches 0, this one drops out, and our limit is 60. If you look, it is this tangent line. It's the place where the line can only intersect the curve in one point. Okay, the distance in feet from a starting point is given by this. Find the average velocity from 2 to 4. So that means we want to do s of 4 minus s of 2 all over 4 minus 2. So now we got to plug the 4 into the equation. So this equals, so we're up here. So we got 2 times 4 squared minus 5 times 2 plus 40 minus, now we got to plug in the 2, 2 times 2 squared minus 5 times 2 plus 40 all over 2. All right, when you plug that whole thing in your calculator, you should get 7 feet per second. All right, now I want to find the exact, so that's average. That's from a point to a point. That's like a secant line. What is the exact velocity at 4 seconds? So now this is the limit as x, or sorry, I gotta erase that. Please erase, there we go. As h approaches 0. Okay, now we're gonna do s of 4 plus h minus s of 4 all over h. Remember our difference? All right, now we got to plug all this in. And we're going to plug it into this formula up here. So we have to do 4 plus h first. So we do 2 times 4 plus h squared minus 5 times 4 plus h plus 40. Oh, I'm out of room. I should have written down farther. Okay, that's your 4 plus h, right? So let's just go over here and do our math again. Sorry about that. Okay, so let's write this here. 2 times 4 plus h squared minus 5 times 4 plus h plus 40. Okay, that's in our first set of parentheses. Minus, we're going to plug in our 4 and take 2 times okay, I hope you plugged everything in right. Now, when you take and you square this out, you should have gotten 2 times 16 plus 8h plus h squared, that's this guy squared, minus 5 times 4, which is 20, minus 5h plus 40. This whole thing back here equals 52 all over h. Okay, let's distribute our 2. And we have 32 plus 16h plus 2h squared minus 20 minus 5h plus 40 minus 52. Oh, I knew I was going to run out of room. Oh. Let's try that again. All over h. Well, now let's see, 32, 20, and 52. So these are all going to cancel. We have 2h squared plus 11h. So now we have 2h squared, this is gone, plus 11h all over h, which is equal to 2h plus 11. Okay, now we're doing the limit as h approaches 0. So now you're doing the limit as h approaches 0. So this is going to cancel out. And your answer is 11 feet per second. Sorry I wrote so big. I hope you did okay. All right, now let's go on with some DVDs and actually put this into some math. Okay, our cost is 100 plus 15x minus x squared to produce x cases of DVDs. Find the average rate from 1 to 5. So that's the same as before. So first we're going to plug in our 5. So 100 plus 15 times 5 minus 5 squared. All right. So that's our C of 5 minus our 1, which is 100 plus 15 minus 1, all over 5 minus 1. Plug that in your calculator and you should get $9 per case. Is the average from 1 to 5. Now, I want to know what's the difference in producing 2 cases compared to 1 case. So this is C2 minus C1. Plug those in and we're going to get 100 plus 15 times 2 minus 2 squared. Okay, now let's subtract our 1, which is 100 plus 14 plus, minus 1. Type that in and we get $12 is the difference from 1 to 2. I want to know the instantaneous rate, so this is our different one, of producing exactly 1 case. So what does it change to at 1 case? So this is our limit. I'll write this one out. As h approaches 0, of c of 1 plus h minus c of 1 all over h. So let's plug this into our formula. So the limit as h approaches 0 of 100 plus 15 times 1 plus h minus 1 plus h squared minus I made a mistake up here. This is 15 minus 1. There we go, because this is 114. So that's C of 1. And so I already know C of 1. We're going to put 114 up here all over H. So let's just do our little math. So that's 100 plus 15 plus 15H. Square this dude out. 1 plus 2H plus H squared. Okay, minus 114 all over H. Let's save ourselves a little time here. So this is minus 1 minus 2H minus H squared. So 115 in this and here. So this and here cancels. So that's 114 minus 114 is gone. We have 15H minus 2H. So that's going to give us 13H minus H squared divided by H, which is equal to 13 minus H. But as H approaches 0, this is equal to 13. So it's $13 at 1. All right, good luck on your homework. I hope you do well.